Good day and thank you for listening. Today I am presenting on behalf of Dr. Luis Elías Piña-Villalpando the presentation entitled Region-Based Approximation Using Segmentation Techniques for the Determination of the Diffusion Coefficient of Topical Substances. This is the proposed index of about the things that we are going to talk you about today. For the motivation and introduction of the project, we want to determine the diffusion coefficient of different dermatological substances within the skin. For this, we are going to use terahertz images produced with terahertz spectroscopy. This technique is very useful to determine the hydration state of different tissues given the high absorption of water in the terahertz band. For this, the use of this kind of images are of interest in order to see how a determined certain dermatological product is going to interact with the skin and produce a different state of hydration after actuating in the skin. For example, glycerin is one of the main ingredients that is used in moisturizing and dermatological products. This is why we have previously studied how the glycerin interacts with tissue using terahertz spectroscopy. After this, we want to use this kind of images not only to see how the hydration state is changing, but also how it is diffusing within the skin. And we want to use different image processing techniques in order to do this. As previously said, we have obtained different terahertz images obtained with terahertz spectroscopy from the interaction of different products with the skin. In this case, we are showing previous results for commercial cream and glycerin. From these images, we have found how these products change the hydration state of the skin. However, now we are asking ourselves if we can use these images and apply some image processing techniques in order to calculate the diffusion coefficient of these substances within tissue. For answering this question, we have the following objectives that we are going to present in this work. First, we want to develop a reliable processing technique for the calculation of the diffusion coefficient of topical substance within the skin. For this, first, we develop and test a proposed imaging processing technique using a known substance in order to evaluate that our processing is given the correct results. In particular, we will use ink diffusing over a layer of water that will allow us to check if our results are correct. Experimentally, the standard problem that we are going to be analyzing is the ink diffusion over water. This experiment was performed under the following condition. First, we have water with low dip in order to assure that the diffusion is only happening in 2 dimensions. Then we have the constant room temperature and a constant volume of ink drop. The picture here shows the experiment that we perform. We have the camera that is going to be acquiring the images for the processing, and in the focal plane we will have a petri dish that will have the water, and the drop of ink will be put there using a micropipette. The problem that we are analyzing is theoretically described by the Fick law and diffusion equation that we are showing in this slide. This is a second-order differential equation where D is the diffusion coefficient that we are trying to calculate, N is the concentration of the substance within the water, in this case the ink, and we are also given the initial conditions for analyzing our problem. A stands for the radius of the drop of the ink that we are putting in within the water. Related with the previous equation, in this work it was shown that the probability distribution to find a diffusing particle in a plane in polar coordinates is given by this equation. From this, we can find that the second moment of diffusion has an expected value for r squared given by a linear equation showed in the second one. Here, d is the diffusion coefficient of the substance that we are trying to determine in terms of the analyzed images. From the previous experiment, we could register different images at different times where we can see that the ink is diffusing in the water. From the previous images, we now start with our image processing methodology, where the first step is to equalize the images, and we equalize the images in order to improve the contrast. The second step is to binarize the image in order to be able to perform the morphologic operations that correspond to the next step. Next, we find the edges in our images. For this, we use different edge detection filters, where the best results were given by the Canny filter. After the edge of the images is detected, we perform several morphological operations, where the principles are object detection, closed contour, and then the determination of the area that will be related to the diffusion coefficient. In this case, the morphological operations can be used to determine different shapes like diamond, disc, or lines at some inclination. In our case, we use them to detect the disc form of the drop that is diffusing within the water. After calculation the area of the drops in different times, we can calculate how the area is changing with respect to time. In this case, we are showing some of the experiments that we performed, where we can see how the area is increasing with respect to time. Taking into account the optical system that we are using in order to record the images, we can evaluate the radius of the drops with respect to time in centimeters squared. Then we see that the functions are very similar to how the area is changing. In order to evaluate how our experimental results are described by the theoretical model, we fit linear tendencies to the corresponding changes in R squared. Here we have two examples where we are starting the fitting from 20 seconds. This is because before we can have electrical diffusion from the ink particles, and these can give a different fitting than the linear that we are expecting. We can also see that the fitting have a R square value very close to unit. Here we are showing some of the results that we obtained from the experiment and our imaging processing technique. Here we are showing the different coefficients for the linear fitting, the R value that is very close to unit, and then the calculation of the diffusion coefficient using the presented model. We can see that from these chosen examples, 3 of them correspond to a value very close to the expected, and only one of them is showing bigger error. As a summary of our talk, we can say that the finded curves represent the expected behavior of the diffusion according to the presented theoretical models, and that the proposed methodology is being accurate in the calculation of the diffusion coefficient. As a future work, we want to perform more experiments in order to check that the difference of the calculated diffusion values are only occasional and our results are very accurate. And also, we will be using the terahertz images with this proposed image processing methodology in order to find the diffusion value of the substance within tissue. Finally, here is some of the bibliography that you will use to perform this work.